Okay, so let's do sine and cosine ratios, okay? Section 8.6. We just did tangent and sine and cosine. We'll go with it, okay? So as a warm-up, I want to think about, have you ever heard of the word tangent before? If you have, what was it? I want you to think about it and come to class to talk about this. So that's your warm-up for tonight, okay? Don't just tell me I never heard of it, or I feel like I heard of it, but I don't know. If you remember, that's great. If not, I want you to take a look. Look it up, okay? We talk about it. Okay, so the objective here is still part of objective 1b. Define the sine and cosine ratios for an acute angle. Acute angle meaning less than 90, not including 90. All right, so here is the sine and cosine ratio. The sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. So here's a summary. Okay, so SOHCAHTOA. That's what SOHCAHTOA is. SOHCAHTOA. Okay, that's the like a quick way to remember it, but means this is the numerator denominator. Okay, so for the angle 26, the sine of 26 is x over 17, and cosine of 26 is y over 17. The sine of 64 is y over 17, opposite over hypotenuse. The cosine of 64 is x over 17, adjacent over hypotenuse. So you realize the relationship here? These are complementary, right? The sine of complementary angles is cosine. Sine of an angle is cosine of complementary angles. We see that a little bit later, okay? So that's the definition, okay? So let's practice using them. Example 1. Find the value of x and y to the nearest integer. So you got two angles and one side. In this case, the side that we know is hypotenuse. So we will know these two sides, right? You know two angles and one side. So if you're looking at sine of 67, opposite over hypotenuse, x over 120. So x equal sine of 67 times 120. So let's go to the calculator and make sure the mode is in degree. Is a radian in degree, should be in degree, okay? Second mode to quit. And what we were doing was, so the button right here, the sine button, you see the sine button right here? Sine of 67 times 120. Enter, and it is, you have to use a squiggle, 110.46. Okay, so that's the length here, and then you do the reality check. This is 120, this being 110 doesn't make sense. It should be shorter than this, but it's not too much shorter, right? And to get to y, you can use cosine of 67 is y over 120, right? So then y is cosine of 67 times 120. Usually these we put in the parentheses here. So cosine is next to the sine right here. Cosine of 67 times 120, right? And then you get the 46.89. And again, it does make sense. And then you can do reality check. For example, if this is 60 degree, right? This is hypotenuse and that's short leg, right? So this would be 60. And this is, the angle is wider than 60, right? So make this angle more acute. So this should be shorter than our special right triangle. So it's less than 60, 46. It makes sense. Next page. Okay, find the value of n to the nearest integer. So you can do this one, I think. This is inverse, right? And this is opposite and hypotenuse. So you do sine inverse. So if you remember, sine inverse, you see the right here, the light blue, sine inverse. So you have to press second and sine to get the sine inverse. Put the ratio in there, and then you get the angle. Okay. All right. Example 3. An isosceles triangle has side of 8 and 6. So sides of 8, 8, and 6. Find the length of its 3 altitude. Now, you got the one altitude here, the other altitude here. The other altitude is over here, right? But since this is isosceles, these are same lengths. So you don't have to do 3. Even though if it's a scalene triangle, you have 3 different altitudes. This is isosceles, so this and this would cover all altitude. So this length, we have opposite and okay, so this angle, okay, so this angle right here, it says 68, but you can't use that because you may get this as a separate problem. So how do you get x here? So these are the problems that you have to be able to switch your brain back and forth from what you learned and what you're doing in this section, because they mix things in here. This is Pythagorean, right? So 64 equal 9 plus x squared. So 64 minus 9 equal x squared. So 55 is x squared. So this x is square root of 55. It's a plus minus, but it's a length, so only plus would count. Okay, and then this is 11 and 5, so you can't simplify anymore. So the x is that. Now this one, you have 6, and this is 90 degrees, and this is angle. They gave you the angle. Yeah. So for this problem, they give you angle. You have to do, since you're trying to find this length, which is one of the leg, and this is the hypotenuse. Now, here is the problem. You have to be able to pick the right ratio. You know this angle, and this is opposite. This is adjacent leg, this is opposite leg, right? So you have to use sine. So sine of 68 is opposite over hypotenuse. So y is the sine of 68 times 6. So sine of 68 times 6 and 5.53. So y squiggle 5.56. And does that make sense? Yes, it does. This is the hypotenuse. This should be shorter, but not much shorter. So that makes sense. Okay. Example 4. The word cosine related to the phase complements of sine. Cosine is complement of sine. Explain the relationship by using a diagram to express the cosine of A and the sine of its complement. Okay, so cosine of A is, this is hypotenuse, this is adjacent. So cosine of A, angle A, is B over C. Okay, and its complement is right here, right? And B over C, that would be adjacent. So that the sine of B is B over C. See, we just briefly talked about this. The cosine of an angle is the same as the sine of its complement. Okay, they have the relationship. tangent of A and tangent of B. We did this earlier. What was the relationship here? You remember the tangent A and tangent B? These are reciprocal of each other, right? So tangent of so in this case, tangent of A is opposite over adjacent, so A over B, and the tangent of B is opposite over adjacent, B over A. Okay, so they have that relationship. Cosine and sine is their complements are equal. Okay, all right. Practice for 8-6. So let's do some of these for homework. 1-3, express cosine A as a fraction. Just do 2. Okay. Using the triangles x 1-3, express sine B and tangent B as a fraction. All right, this one. So for 2 only. Okay. And maybe do 3 too. Okay. And use the table or calculator, not the table, the calculator, to complete the statement. I think you should do this all. Okay. Do all. Oh, sorry, you couldn't see. Use a calculator to get them all. Just get used to using calculator for the inverse and the regular. And state 2 different equations you could use to find the value of x. So what it's saying is to find x, you can do sine of 41 equal x over 100, or you can use cosine of 49 is x over 100. That's what it means. Okay, so do 9. Okay, and the table on page 11 lists 0.5 as a value of sine 30. This value is exact. Explain why. I want you to think about this. Okay, we talk about that. And suppose the sine of n is 5. This is 5. 5 over 13. Find the cosine of n and tangent of n without using the table or calculator. So just answer in fraction. Okay, do this. If sine of n is 5 over 13, you know the what the others are in fractions. Okay, according to the table 311, sine of 1 degree and tangent of 1 are both approximately this, which is actually larger. How do you know? So one thing you can do obviously is to use calculator, right? And then, but that's no good reason. But let's just check. Sine of 1 degree is that, and tangent of 1 degree is that. So it's exactly the same until 1, 2, 3, 4, 5, fifth decimal place. It starts to get different on 6. So tangent is actually bigger. So the question is why? Why? And how do you know? How do you know it will be a calculator? So why is it bigger? So I want to think about that. Okay, these are all good questions. And using the definition of sine, explain why the sine of an acute angle is always less than 1, and is the cosine of actual angle always less than 1. Okay, I want you to think about these too. These are very good thinking problems, and we go over this. So if you don't know what to answer with this is okay. I just want you to think about, especially this one. Using the definition of sine, explain why the sine acute angle is always less than 1. It's not gonna be, it can be 1. Actually, you are not using 90 degrees, so no, it have to be less than 1, and it cannot be 1 for this class. Okay, so I want to think about that, and we are done.